Assalamualaikum warahmatullahi wabarakatuh and very good morning. Today we're going to proceed with the second part of this chapter, periodicity. Main objective of these parts are to describe the variations of atomic radius across the period and down the group, to define ionization energy and describe the variation of ionization energy across the period and down the group, and the last objective, to define electronegativity, describe variation of electronegativity across the period and down the group. Periodic trends or periodicity. A periodic trend is a pattern observed on the periodic table for an atomic property. Each of three trends have explanation for their group trend and their period trend. The three main periodic trends are: one, atomic radius. We're going to discuss radius across the period and down the group. Second, periodicity, ionization energy across the period and down the group. Last one is electronegativity, the variations across the period and down the group. Period trend explanation. In order to explain periodicity, you should understand the main important factor. There are two trends. The first one is explanation across the period, and the second one, explanation regarding down the group. For explanation of periodicity across the period, the main factor is effective nuclear charge. Means that if the elements are in the same period, you need to discuss regarding effective nuclear charge. Effective charge is the net positive charge experienced by electron in an atom. If the elements in the same period, the atoms on the right of the periodic table will have higher effective nuclear charge compared to element on the left. This is due to the electron being added to the same energy level. They are approximately the same distance away from nucleus. So therefore, in general, the further atoms are away from the nucleus, the less attracted they become. For the group trend explanation, when we compare atoms in the same group, group 1, group 2, group 3, compare the amount of electron shielding. Electron shielding is where core electron shield outer electron from the charge of the nucleus. Thus, outer electrons are held less tightly because of electron-electron repulsion. Explanation. Atoms on the top of periodic table have less electron shielding than atoms at the bottoms. As you increase in the number of energy level, more electron shielding occur. This does not occur across a period as energy level will not change. So this is down the group. You can see for period number 1, we only have one shell. Period number 2, we add another shell. Period number 3, shell. Period number 4, there are 4 shells. As conclusion, in order to explain periodicity, you need to remember the key point. If you discuss the trend across the period, you have to discuss about effective nuclear charge. If you discuss the trend down the group, the main factor is shielding effect. The first periodicity here is atomic radius. Atomic radius. Atomic radius is a measure of the size of the atoms. Size of the atom measured by the distance from the nucleus of the outermost electron. The first periodicity that we're going to discuss is radius. As conclusion, atomic radii decrease moving across a period and increase going down a group. Across a period, size of atom decrease. Down the group, size of atom will be increased. In order to explain, so for the across a period, remember that when we discuss the period, we need to discuss about effective nuclear charge. For across a period, with effective nuclear charge increase, it will increase positive charge, pull electron closer, causing the size to decrease. Down the group, the increasing energy level provide more electron, which increase the size of atom, increase electron-electron repulsion, causing the size of atom increase. Second periodicity is ionization energy. Ionization energy is the energy required to remove an electron from an atom. Amount of energy increases as the number of ionization energy occur. For example, first ionization energy take less energy than the second. Ionization energy increase going across a period and decrease going down a group. With increasing effective nuclear charge, electrons are held more tightly, thus atoms on the right require more energy to remove an electron. Down a group, with increasing electron shielding, electrons are held less tightly and thus decrease in ionization energy. Electronegativity defined as the ability of an atom in molecule to attract shared electron to itself. Electronegativity increases going a period and decreases going down a group. Across a period, due to the increasing effective nuclear charge, atoms on the right hold electron more tightly, causing them to have higher electronegativity. Down a group, due to the electron shielding effect, atoms on the bottom tend to hold electron more loosely, making them have electronegativity. Noble gases are excluded from this trend as they tend not to bond with other atoms. This makes fluorine the most electronegative atom.